Hello people, welcome back to this new video. I'm Srinidhi here. So in this video, today we're gonna learn the different types of interrupts with respect to your ARM7 processor. You people already knew that how many types of interrupts or exceptions are there. We have about 7 types of interrupts. Okay, so depending on the operating modes we classify, we have different 7 interrupts we have. So modes of operations, we have about 7 modes of operations, and the interrupts, okay, is applied on 5 modes. Okay, 2 modes doesn't require any interrupts. Okay, the rest 5 modes requires interrupts to enter its modes. Okay, so we have all these types of interrupts. Okay, so reset and software, which is the SVR supervisor mode. Okay, we have reset, undefined, software, prefix abort, data abort, IRQ and FIQ. We shall just see first which interrupt enter into which mode. Okay, if you have seen my previous videos, I think it will be definitely a cakewalk for the first half of this video. Definitely I would explain this video, because few students, if you want to learn this concept directly, if you have come across this video directly, it would be a definite answer for you people. So this is an important question for your examination point of view. Interrupts are a very important concept that you must know for the better understanding of the internal manipulations, how your mode changes or how your interrupt gets into different modes. Okay, what are all the types of modes which we have? We'll start here. See, first type of interrupt is your reset. So reset means what? Which you are starting your system. Okay, which you switch on your system. What is the first program? It is definitely concerned with your BIOS program. Okay, starting initial program. See, when you start with your initial program, see, you don't like it will enter into supervisor mode. It won't enter into system mode or the user mode, right? As soon as you power off, switch off, or switch on button is pressed, it won't start displaying any movies or the favorite images which you want to see. Okay, those images or movies will not be displayed over there. So instead it enters the supervisor mode, where it is concerned with the BIOS program, so internal execution, and invokes the rest all other programs. Okay, is being started with respect to your reset. Next we have undefined interrupt. Okay, usually you know when undefined interrupt occurs, there is no execution flow of instruction, those libraries which are not present in that particular process to execute. For example, divide operation is not possible in this processor at that point of view, and if the same operation it search for the coprocessor, if it's not available with respect to those coprocessor also, it enters into undefined mode. So interrupt which occurs for undefined mode, it enters into undefined mode. Okay, it is undefined interrupt which enters into undefined mode. Okay, next we have software interrupt. Okay, software interrupt, I told you, it is mainly concerned with starting an application or killing an application or stopping an applications or uninstalling or installing an applications, where you enter, where you will be residing in the user mode, in which you enter into kernel mode or the system mode. Okay, so that is where we enter from to supervisor mode, which we call it as a system mode. Okay, supervisor mode will be entering. So 2 modes enter supervisor mode. One is your reset, another one is your software interrupt. See, both the types of interrupts actually enters this particular mode, which is supervisor mode, but the reason when it enters is quite different. When does your reset enters? That is with respect to your starting the system, that is when you are starting your BIOS program is being run. When does your software interrupt occurs? Which is with respect to installing or uninstalling an applications, which is related to your system calls. Okay, so next we have prefix abort and data abort. Both the things enter into abort mode. I told you that abort mode, when does your system enters your abort mode? See, I think if you have watched my previous video, definitely you have your answers within your hands now. I'll tell you once again. We have, let's say, you know that memory, in memory it is classified like the system program and system data, user program and user data. Okay, so system program can access user program or user data, but user program cannot access your system program or system data. When, I'll repeat it again, system program can access user program or the user data, but your user program nor the user data cannot access your system program or system data. Okay, if it tries to access your system program or system data, the system enters into which mode? Abort mode. Which kind of interrupt occurs? It is two types of interrupts, that is prefetch abort and data abort. So prefetch abort means when your user program start accessing system program, we call this as prefetch abort. Okay, prefetch means what? We are fetching an instruction that is nothing but your program, that is prefetch abort. Next, if you are starting, that is your user program start to access your system data, we call it as data abort. Okay, so prefetch abort and data abort are the two interrupts which enters your abort mode. Next, we have last two types of interrupts, that is your IRQ and FIQ. Okay, I have already explained this concept when we have studied in the previous video, that is with respect to your types of interrupts, okay, or the software model, how it is being classified. So when IRQ and IRQ enters IRQ mode, that is normal interrupt request. FIQ is fast interrupt request, in which I told you the difference between the both IRQ and FIQ. IRQ uses memory. Since the ARM does not allow memory operations, we go for FIQ. You see, in FIQ, that is fast interrupts, we have dedicated 5 registers, that is from R8 and above, R8 to R12, R8, 9, 10, 11, 12. That is 5 registers that is being kept dedicated to work with FIQ. Since the registers work with FIQ, it enters into FIQ mode. So this is with respect to your interrupts and which mode your interrupt enters. Okay, which mode your interrupt makes your system to enter. Okay, so this part is done. Now we have the concept of next we need to know what is this low vector and high vector. Before we know low vector and high vector, I want to tell you what is vector address is. Okay, so when, let's say I start with my instruction I1, so soon after I start with the instruction I1, if I want to tell that an interrupt occurs, so it start executing your ISR. So your address of ISR must be fixed. Okay, it cannot be changed with respect to your ARM processor, whereas your in case of 8051 and 8086, it's gonna change. Okay, but with respect to your ARM7 processor, see people, please listen to me guys. Okay, with respect to your ARM7 processor, the ISR address is not changed, it is fixed. That fixed address, we call it as a vectored address. Okay, so vector address is the fixed address of ISR. Now we also have a non-vectored interrupts. Okay, or vector, we classify interrupts as vectored interrupts and non-vectored interrupts. What do you mean by vectored interrupts? All interrupts have the fixed address. Okay, each and every interrupts will be having a fixed address. What do you mean by non-vectored address? Each and every address will be of variable address. Okay, they have different address location. It can be changed. So that in 8086 we had the concept of INTR, right? Okay, okay, in INTR it gonna change for with respect to different types of interrupts, but in ARM7 the address of every interrupt is fixed. Okay, so now here we have low vectors. Low vectors means we have the memory, right? So in ARM it starts from 0, 0, 0, 0 and it ends with FF, FF. Okay, so it starts from 0, 0 and FFFF. I don't want to make it very much slow, and we'll go at least little bit, we'll try to understand it very quickly. Okay, it starts from, your memory start with the address 0, 0 to FFFF. okay, so that your total memory is of how much? 4 GB memory in your processor, okay. The low vectors means, see, we have the concept in memory. We have two types of memory. One is your ROM and another one is your RAM. Okay, RAM means what? It is random access memory, that is, it is volatile memory, and your ROM is a non-volatile memory. When you switch off the system, the memory which was present inside, the data which was present inside the RAM will be erased, whereas with respect to your ROM, it will not be erased. Okay, these things you have already known in your PU or somewhat in the high school level also when you started learning computer science. Okay, now my question here is, so where should I place my ROM here? Should I place my ROM here and RAM here, or my ROM here and my RAM here? It mainly depends on your perspective, students. Okay, it really doesn't require where we start. If I place my ROM here, I will call this as low vectors, where I am starting with. If I place my ROM here, I will tell that high vectors. I am starting my address with high vectors. Okay. Now let's come to this vector address of each vectors here. It starts with 0. From 0, next it is 0004, 8, C, 10, 14, 18 with the displacement of 4. Now you can ask me one question, where is 0014? See, 0014, that one particular address in ARM, I haven't represented here. Why? Because there are two interrupts which lies between your data abort and your IRQ, which those two interrupts were used in the previous versions of ARM, which I am not using in this particular version of ARM. So I just kept it idle. I am not disturbing that particular address, but still it exists, which I don't make use of it. Are you people understanding what I am telling you? Okay, so I haven't taken 0014 here. Instead, everything, it starts from 000048 C, okay, and it ends at FIQ is 001C. Okay, if you observe the difference here, 00002, 0004 means you have, in between these two, you have 4 bytes of difference. Okay, why do we require 4 bytes of difference? Any operations or the request can be written in between. The jump instruction can be, or the loop iteration instruction can be written in between your 4 bytes. Okay, that is why we have 4 bytes difference. And please students, it's very easy. There is nothing much to by heart. It is just fixed. You don't have to worry about this is what the address of this particular instruction, and this is huge. Okay, you don't have to be worry about this kind of address. Address is fixed with a displacement of 4, with a difference of 4 bytes each. That's it. 0014 is not there. Again, this is with respect to low vectors. High vectors, instead it started with 0. Here I will be starting with F, and the rest all other address will be same. Now tell me, did you understand this concept? Okay, did you? I hope so. I just tried my level best to make the things very much simpler. Okay, there is nothing complex here. Well, I'm just giving the reasons why they are giving. What is low vectors? What is high vectors? I have tried to convey you people. Now, this is one part. You have understood what is interrupts, which mode will be entering when one particular interrupt occurs. What are the types of address that we have? We have two types of address, that is low vectors and high vectors. Okay, depending on where we place the ROM, where we start with the ROM, it depends on that particular thing. See, at last we have one more concept with respect to your interrupts. When an instruction starts its execution, when it want to enter the interrupts or the ISR, it has few things to make. Okay, if you have watched my previous videos, it will be definitely an easy thing. There are few changes that it gonna happen. Okay, if you have observed the registers programmers model in the previous video, I have taught you what are all the changes. I just want to give a quick revision of what. See, your CPSR will be changed to will be stored at SPSR, so that your current point stack values will be, flags will be stored at one particular place, that is SPSR, before it jumps into ISR, and then your more bit changes in your CPSR during your execution. That is, when we studied the concept of CPSR, the last mode we have, the mode bit in CPSR, that mode bit will change. Why? Because it is changing from user mode to any other mode. That is, it is entering that it's gonna start executing your ISR. Next, it activates the new register. When it start entering the different mode, new registers gonna start over there. Next, at last we have it will make the thumb bit as 0. See, this is my interrupt, this is my user or the instruction during the execution. If my control transfer, I want to transfer my control from instruction to your ISR, these changes gonna make. Okay, your ISR is fixed, it does not change with respect to any mode with which it has been changed. With my normal instruction, if I have my thumb instruction, these I don't have any thumb bits which is allocated for my thumb instruction. If we are having a normal instruction with normal registers, dedicated register, okay, I just shift it directly. Anyway, if I want to make, if there exists some thumb instructions or thumb bits here, I'll make those thumb bits as 0 before I enter into ISR. So it has the thumb bit or it doesn't have the thumb bits over there. I just make my thumb bit as 0 here. Okay, did you understand what I am telling now? Okay, so this is what the changes, 4 changes it's gonna make. As I told you in the register programming model, we knew that PC is stored. Where is the value of PC is stored? PC is all obviously stored in LR, that is your link register. So after completion of your ISR, again while coming back, your content of LR will be stored back to your PC. Okay, so that is the ISR address, LR will be copied to PC. That is, your CPSR value will be stored back to your SPSR will be stored back to your CPSR, and your LR will be stored back to PC. See, LR, the contents of LR will be stored back to PC means it will cover multiple operations. Guys, please do hear me. If the contents of LR is copied back to PC, what are all the changes that here, all the mode bit will be changes again, and all the, see, it will reactivate all the previous mode registers also. There are different modes of registers which it's gonna change when it enters different mode. So those changes which happened when your processor entered from a user mode to the interrupt mode, or when it start ISR routine, after completion of the routine, you want your bits or flags or anything, you want it to be unchanged, so those registers will be reactivated. Okay, each and every, your interrupts is also represented. We have different types of register. Those registers will be reactivated when it comes back to your normal instruction, okay, or the next instruction to be executed. So this is what the execution flow it has. So I hope so you understood this video. Please watch it once again if you have any doubts with respect to this. If you have come across any doubts, or if you are not confined with the concept, just let me know in the comment section so that I could improvise myself, so that I could still break down the concepts and let you know. And of course, it's quite an important concept. Please concentrate and do well. All the very best. Bye bye.